Hello students, this is the last session of this unit second. So in this session, I want to discuss some miscellaneous topics. These topics are mentioned as separate points in the syllabus of unit 2. So I want to end this unit with these topics: mining pools and mining difficulty. Already we have studied these topics, mining pools and mining difficulty. So instead of starting the new unit third in this week, I will start the unit third in the next week. So we will discuss some miscellaneous topics like mining pools and mining difficulty, and then we will complete this unit. So mining pools, already we have studied what is mining pool. What is mining, mining, in mining, uh, the miners will try to add a block in the blockchain, and for mining, miners has to solve the mathematical puzzle. In proof of work, in proof of stake, miners are called validators. Validators must possess a certain number of coins in the Bitcoin network. Then we have studied proof of uh, burn. In proof of burn, a miner has to burn the coins, and larger the coins miner will burn, the greater is the chance that the miner will be selected to propose a block in the Bitcoin network. Then we have studied the proof of elapsed time also. This is also one of the mining algorithm. So we know that miners get reward for adding the block in the blockchain or Bitcoin. And in proof of work, miners require a high performance computer. So mining pool is the concept where instead of individual miner, the group of miners will work together to mine a block, and this group of miners will form a mining pool. So you can read the first sentence. A mining pool forms when group of miners work together to mine a block. So instead of one solo miner, one miner trying to solve the mathematical puzzle, group of nodes, group of users will come together, and they will try to solve the mathematical puzzle. And when the mathematical puzzle is solved, when these miners will mine a block, then this transaction fee or reward is distributed among the miners. And the mining pools are controlled by the pool manager. So after mining a block, the pool manager will receive the coin based transaction if the block is successfully mined. Successfully mined means if the block is successfully added in the blockchain or Bitcoin network, then the pool manager will receive the coin based transaction, and which is then responsible for distributing the reward to the group of miners who invested resources to mine the block. So in this mining pools, group of miners will work together to mine a block, and pool manager, to the pool manager controls overall activity of these mining pools. Pool manager will receive the coin based transaction if the block is successfully mined, and if the block is successfully mined, then pool manager is responsible for distributing the reward, for distributing the transaction fee to the group of miners who invested their resources to mine this blocks. So this is profitable as compared to the solo mining, where one sole miner is trying to solve the partial hash inversion function. The one miner is trying to solve the hash puzzle, or we can say mathematical puzzle, because in mining pools the reward is paid to each member of the pool, regardless of whether they solve the puzzle or not. So each miner will receive some reward, some fee. This is the advantage of this mining pools. So in mining pools, a pool manager will control all the operations. There are various models that a mining pool manager can use to pay the rewards to the miners, or you can say transaction fee to the miners. So there are two models for paying the transaction fee, or you can say reward to the miners. First model is pay per share model. This model is called PPS model, and other model is proportion model. So in the PPS model, the mining pool manager pays a flat fee to all miners. The pool manager will divide the reward equally, and that equal contribution is paid to each miner who participated in the mining exercise, the miners who participated in solving the puzzle. That miners will get the equal uh, reward. The reward is distributed equally. So in the PPS model, the mining pool manager pays a flat fee to all the miners who participated in the mining exercise, whereas in the proportional model, the share is calculated based on the amount of computing resources spent to solve the hash puzzle, or you can say mathematical puzzle. So in second model, proportional model, how much computing resources are spent by the miner, depending on that the fee is calculated, the reward is calculated, and reward is distributed based on the computing resources engaged by the miner to solve the mathematical puzzle. So in this proportional model, the mining fee is not equally distributed, but the mining fee is are calculated based on the amount of computing resources utilized by that miner, by that node to solve the puzzle. So these are the two methods to pay the fee to the miner: pay per share model and proportional model. Pay per share model, in this first model, the fee is distributed equally, and in the second model, the depending on the resources spent, resources utilized by the miner, depending on that the fee is calculated. This is the role of this mining pool manager in mining pools. So mining pools is the concept where the group of miners, instead of the individual miner trying to solve the puzzle, the group of nodes, group of computers, group of users, a group of miners will try to solve the puzzle, and the miners will get the, each miner will get the fee. So in first model, if fee, every miner will get the equal fee, that is pay per share model, and in proportional model, depending on the amount of resources spent, the mining fees are calculated. Then there are some commercial mining pools. These mining pools, in these mining pools, the group of nodes, group of users, group of miners come together. So there are some commercial mining pools that exist, and there are two examples. There are two most commonly used mining pools: Ant pool and BTC at top. So many commercial pools now exist and provide mining service. There are many commercial pools that provide the mining service contract via the cloud and easy to use web services. And examples of this commercial mining pools that exist and that provide the mining service contract. That commercial examples are Ant pool and BTC top. Then 51% attack, we know that what is 51% attack. If the 51% miners that come together, and if they try to manage the network, so these miners get the power. If the more than 50% miners come into the come together and they can attack the system. They can execute the successful double spending attack, and it can impact the consensus mechanism. So in 51% attack, mining centralization can occur. This 51% miners can try to control the system. This 51% miners can calculate the hash value, and they can breach the security of this Bitcoin network. So in this case, monopoly problem may create. Monopoly means the miners will come together and they will try to attack the system. They will try to manipulate the system. These miners get the power to misbehave in the system because they hold the 50%, 51% share of the total Bitcoin network in terms of their mining capacity. So mining centralization can occur if a pool manages to control more than 51% of the network. If the mining pool has more than 51% of the network by generating more than 51% hash rate of the Bitcoin network, a 51% attack can result in successful double spending attacks, and it can impact consensus and in fact impose another versions of transaction history on the Bitcoin network. So such type of 51% attack has happened once in the Bitcoin history. Once the miner come together and they will try to breach the system. They try to attack the system. So this event has happened once in the Bitcoin history when ghash.io, a large mining pool, managed to acquire more than 51% of the network capacity. So such type of attack happen once in the Bitcoin history. So we know that another topic that we have to study in this session. Already we have studied this topic and we have done lot of discussion on this topic also. The difficulty is a measure. How the difficulty is to mine a Bitcoin block, or in more technical terms, to find a hash value below the given target. So we know that in Bitcoin network, in proof of work, miners has to solve the mathematical puzzle, and miners has to solve the mathematical puzzle in such a way that it has to find the hash value. That hash value should be below the difficulty target. It should be below the difficulty target, and this difficulty target is adjusted in such a way that the time required to generate a block, to create a block, it should remain 10 minutes. It should be 10 minutes in such a way that this difficulty target is adjusted. So it depends on how many miners are there in the network, on how many miners are trying to solve the puzzle. Depending on that, this difficulty target is adjusted. High difficulty means that it will take more computing power to mine the same number of blocks, making the network more secure against the attack. So if difficulty level is high, then it will take more time to calculate the hash value, and it will require more time to mine the block, to add the block in the network. And powerful machines, powerful computers, high performance computers only can solve this type of difficult mathematical puzzle, and this makes the network more secure against the attacks. So difficulty adjustment is directly related to the estimated mining power, estimated in the total hash rate. So this difficulty is, adjustment is directly related to the mining power of the nodes, and how many nodes are participated in the mining process. Depending on that, the difficulty level is adjusted. So it will change depending on the number of nodes and the computing power of the nodes that are participating in the mining process. So the difficulty is adjusted every 2016 blocks. That means the difficulty level is adjusted after every 2 weeks approximately, so that the average time, what is the purpose, why the difficulty level is adjusted? Difficulty level is adjusted to keep the time, 10 minutes for each block mining. So the difficulty level is adjusted in such a way that average time uh, to add a block in the Bitcoin network should remain 10 minutes. It should be always 10 minutes, and to keep the time 10 minutes to add the new block, the difficulty level is adjusted. Sometimes difficulty level is reduced and sometimes the difficulty level is increased. So this time is adjusted such that the time to add the block will remain 10 minutes always. So this is the rule for adjusting the difficulty level. The main concept behind this difficulty adjustment is that to maintain the time, it takes to process one block at around 10 minutes. So to add the block, it takes around 10 minutes and it should remain 10 minutes always. So to maintain the time, it takes to process one block at around 10 minutes, and difficulty has to be adjusted periodically. Difficulty should be adjusted periodically so that this time will remain always 10 minutes. It should not be less than 10 minutes. In such a way, this difficulty target is adjusted. What is the importance of difficulty target? When we solve the mathematical puzzle, the miner has to solve the mathematical puzzle, and miner has to calculate the hash value. That hash value should be less than difficulty target, and this difficulty target has to be adjusted periodically to make to remain the time 10 minutes. The time should be always 10 minutes to mine block. So in each hour 6 blocks are mined, or we can say 6 blocks are added to the Bitcoin or blockchain network. So adjusting the difficulty, we know that how to adjust the difficulty. The mining difficulty of a cryptocurrency such as Bitcoin indicates how difficult and time consuming it is to find the right hash value for each block. And mining difficulty is measurement unit used in the process of the Bitcoin mining, and difficulty indicates how difficult it is to solve the complex cryptographic puzzle, or we can say mathematical puzzle. And the difficulty of mining new units, the difficulty time, the difficulty of that puzzle, mathematical puzzle unit, that mathematical puzzle increases or decreases over the time. The difficulty level may increase or difficulty level may decrease over the time, depending on the number of miners in the network, and also the computing power of the miner also. This difficulty is periodically adjusted to keep the time fixed of 10 minutes for adding each block in the Bitcoin network. So it increases in difficulty are necessary. Increase in the difficulty target is necessary in order to keep the target block time fixed, that is 10 minutes. So we have studied this concept in previous sessions also. So students, here is the end of unit 2. We have completed the unit 2. In that we have studied the Bitcoin peer-to-peer network, Bitcoin currency, then how the transactions are processed in the Bitcoin, what is mining, what is the role of miner. Then also we have studied different consensus algorithm, what is consensus mechanism. We have studied Hashcash. We have studied different consensus algorithm like proof of work, proof of stake, proof of burn, proof of elapsed time. So here is the unit 2nd, and from the next week we will start unit 3rd. Students, I am trying my best in such a way that you will understand this concept of blockchain technology. But if you are finding difficulty, you can go on the YouTube. On YouTube various videos are available for each topic, so you can listen that videos also, so that your concepts will become clear. Also you can listen the lectures of Dr. Sandeep Chakravarti. These lectures are available on YouTube. This is the course by the IIT Kharagpur on the blockchain technology by Dr. Sandeep Chakravarti. You can watch that sessions also. So thanks for watching this session. Goodbye.